Our next speaker is Holly Bridgwater, an exploration geologist and currently industry lead crowdsourcing at Unearthed. Unearthed is a unique company working to bring startup innovation to the resources sector. As many of you are aware, earlier this year, Unearthed ran the Oz Minerals Explorer Challenge, and Holly was instrumental in the operation of this challenge and is at the forefront of the use of digital innovation in the minerals industry, applying startup-led innovative thinking to exploration challenges. Holly's talk will cover the current trends in big data science and the future for mineral exploration. Please welcome Holly.
Thanks very much, Peter, and thanks, Anthony, for the invite today as well. It's great to be here. I am going to talk a little bit about trends in data science, particularly around mineral exploration. And I think it's a really appropriate talk to come after what Ursula was talking to you about, and there's going to be, I think, a lot of these trends that we're seeing which are going to be really impacted by this really great work to make data a lot more accessible. So I do want this to be kind of practical as well, and to say, as an exploration geologist, how do we actually use data science and machine learning in a practical way, and what are the trends that we're seeing that make practical differences to our workflow? And at a really high level, we can kind of break this down into where we can use data science and machine learning to automate processes, particularly around data collection. We're seeing a lot of applications of data science to really automate a lot of the manual tasks that we do. But we're also looking to data science to fundamentally help us explore better. And we'll talk a bit about that in terms of particularly machine learning applications for targeting. Can we use machine learning to actually increase our discovery rates because we're actually able to see things in the data we haven't before? Setting the scene with a little bit of background to give us a bit of a global context. Machine learning has been around for a really long time. I'm sure many of you in the audience have used machine learning in your workflows for quite a while now. But we are at a unique time in history and to see this big boom in applications of machine learning because of a couple of key trends. The first one I've got here is around that connectivity, compute power, and data access. All of what Ursula was sharing with you before, you can access that data now in an instant and apply models to it almost straight away remotely. It's incredible the amount of data that we can access and apply models to really, really quickly, and that's what's causing a lot of the trends that we're seeing. Likewise, as you see Mark Zuckerberg up here, machine learning has practical applications now in all areas of our lives. So we've all got our phones on us, anyone talking to Siri, anyone looking at Facebook suggesting you to buy stuff. Everywhere we look, there's a form of machine learning that's influencing our lives, and we're bringing those practical applications now into our industry as well. So those are kind of super high-level trends that are good to be aware of in terms of what that means for industry as well. 5 minutes, I'm going to go super fast. Okay, so because I've got a short time, I'm going to focus on a couple of key areas on the within the exploration value chain. So we are seeing applications of machine learning across the whole exploration lifecycle, so happy to talk more about companies doing that after the talk, but I'm going to focus on two key areas, which are that applications for machine learning and target generation, and then particularly around core logging as well. We're seeing a lot of companies focusing on extracting quantitative data out of photography particularly. So I'll touch on that one just quickly. These are 4 companies. There's quite a few more doing that, but these are examples now where it's established technologies that are able to extract data, quantitative data from core photography. So the top image there you see is from Imago, and that is automated outlines of sulfides, and that has a quantitative sulfide calculation as well. And the bottom image there is from Datarock, which is around establishing kind of lithology boundaries and things like that. These technologies are readily available off-the-shelf products now that you can use to really automate a lot of that data collection from your drill core. Ooh, sorry, someone's calling me. But I'm going to focus a little bit more on the targeting aspect particularly, and these companies listed here are all focused on applying machine learning and exploration targeting. Why are there so many companies looking at that now? It's largely because we've seen that decline in discovery rates, but still a lot of exploration activity, a lot of data being collected. So there's this wealth of data out there, which we know there's so many data layers now that we collect that we can't, using the human brain, process these. So machine learning is a great application to really look for patterns in that data that we can't see ourselves. And all of these companies up here have different business models that are looking at that problem in different ways. So I'm going to touch on a few key trends that we're seeing within this kind of group of companies. This one is interesting, and this is something that, I don't know if you guys are aware of this company, Cobalt Metals. This is the first time we're seeing some of the world's richest tech entrepreneurs invest in mineral exploration. The rationale behind this is that they are trying to search for ethical sources of materials. So Cobalt Metals is a machine learning exploration company that is looking at exploring for cobalt. Sorry, I've got my timer already running over. So this is interesting for us because it can fundamentally change the investment landscape in exploration. The other thing is we're seeing a bit of a trend around the race for the biggest data set. For those of you that have worked in machine learning and exploration targeting, we do see that there is this trend around the way people use machine learning is by looking at patterns of known deposits and trying to find them elsewhere. So what that means then is the more known deposits you have in your database, the better your model should be. So the race then becomes for actually the biggest database rather than actually the tech itself. So you see this company there, Goldspot, they founded in 2015. They're saying their first mover advantage is that they've been able to compile more data than anyone else. And this then really links back into what Ursula was saying, and why that's so important is that Goldspot spend 90% of their time cleaning data. So that's why they think the first mover advantage is very real, because no one else can catch up to them. And that's where the stuff that the survey is doing here is incredible, because this can be a complete game changer for this stuff. If that company doesn't have to spend 90% of their time cleaning their data, imagine what they'll be able to do from a model and analytics point of view. So this is a bit cheeky. This is not really a trend yet, but I want it to become a trend, so I put it in there. This is from the Explorer Challenge, and one of the really interesting outcomes from the Explorer Challenge were that we were able to combine all the kind of 37 different approaches into one heat map, and you can see that map there on the right. So that map is showing you where that hot colors are, where there's many models predicting the same target. So this is very, very interesting, because we know in geology that there isn't one model that's correct, there isn't one approach that's correct, but this consensus approach allows us to compare and contrast models and helps us build confidence, because more than one model is predicting the same thing completely independently of each other. So just to wrap up, because I did want to talk about little practical issues, a couple of questions that we often hear is, as a geologist, as an exploration geologist, should you use machine learning or not? Is it worth the investment? Obviously, it does depend, but there are some off-the-shelf tools now which you can try for automating your workflows. I might just skip to the end question and skip back, and how you pick to work with. My advice, if you're looking to apply machine learning to targeting, is try and find a company that's going to work really, really close with your geologists, because that's where those technologies come together. Think about people that are going to be on the ground, that are going to be able to validate with your team, and then you can work out together how the technology works, because it is developing and it is new. And lastly, should you do it yourself or should you learn? I actually recommend that as a geologist you do a bit of an introduction to machine learning. It's super helpful to understand a bit about it. I've put that fast.ai on there. That's a general course. It's not related to geology, but it will give you a really good insight. So that was a super quick 5-minute introduction, 15-minute introduction, sorry. Oh, I actually gave myself 5 minutes, didn't I? I've run way too fast. I just realized that we've literally gone for 10 minutes, not 15 minutes. Let's go back. We'll go and talk about some of these in more detail. It's going to be really messy for the video, sorry. This is when you don't use your own timer, okay? It was supposed to work and it just didn't. All right, so I gave you a really fast 10-minute introduction to this, but I'll go back to some of these companies to talk about their business models in a little bit more detail. What is interesting here, and another trend we're seeing, is we talked about why people are so interested in applying machine learning to exploration, because there's a huge opportunity in terms of using data in a different way to identify new deposits. And if you think about that, a lot of these companies are changing their business model. A lot of them started out as consultants, providing a service back. And then they realized, you know what, actually, if this really works, it's better for me if I actually have those projects myself. So you're seeing a lot of these companies pivot from kind of consulting service companies to actually either owning their projects outright or having royalties in those projects. So that's something to be aware of if you are an explorer and you're kind of looking to these companies to do some work. It's a bit of a changing game, in that now people are saying, this technology is so good, I can make way more money if I just find those projects myself and then actually sell those projects on or get some royalties. So that's another interesting trend on those, and I would encourage you to take a look at some of those companies as well. I won't go back to Bill Gates, but I will go back to this one and that biggest data set, and I think we don't want to underestimate the power that the Australian public data sets that we have, and because we have the regulations that we do have made a global impact into this field. No one else in the world has the high-quality data sets that we do, and that's been enable people to build these models, because the more data they have been able to test and use those examples within the data set. So all of that work that Australia has done has taken the whole world forward in this technology, and that's really fundamental, and it keeps improving. So this work that is being done here to make that data cleaner and more accessible is going to have a really, really big impact. And yeah, I think that is, every company in that list I showed you before is still having that challenge, because a lot of the data that they get is from private companies, whereas they don't have the same drivers or ability to influence global standards, which is what we're doing here. So this will make a big difference for them. All right. I think I probably have got close to the end now. I've got a couple more minutes. The consensus piece, I think, is something that at Unearthed, at least, we think this will be a really interesting thing to watch because of that ability to combine independent models. We really do not have a set machine learning approach that we know that works better than another one in exploration targeting. So you may hear a bit from the next speaker in detail about some of those methods, but what we learned from Explorer was that each of those 37 models that were put forward used different types of machine learning approaches. Some were more explainable, some were more black box, that you might say, and combined geological knowledge with the machine learning in completely different ways. But each one was valid. So that's something to really think about. Because we do have this whole plethora of valid models, how do we actually compare and contrast them? So what we can do in the consensus approach is really look at that and say, oh, which type of approach predicted this? And did a machine learning approach predict this, or did a geological approach predict this in completely different ways? And I think that's probably me wrapped up now. Thanks.